So we've all heard of Jupiter, the largest planet in our solar system. But did you know that there are other Jupiters out there? So we live on a planet called the Earth that orbits a star that we call the Sun. But there are billions of other stars out there, and it turns out that many of them have their own solar systems with worlds of all shapes and sizes that we call exoplanets. Now, I am interested in a very particular type of exoplanet called hot Jupiters. These are gas giant planets, just like our Jupiter. But unlike Jupiter, they orbit really close to their host stars. So close that they have orbital periods of less than a few days, or in some cases, even less than a single day. So, what that means is that while it takes the Earth 365 days to go all the way around the Sun, it would take one of these less than 24 hours. It sounds like science fiction, but it's real. And the existence of these begs some questions. How did these massive planets get so close to their stars in the first place? Would it be possible for other planets, perhaps harboring life, to exist in the same system? Understanding the behavior of these ultra close in hot Jupiters will help us answer some of these questions and more. Now, I am most interested in the future of these strange planets. Theory predicts that many of them should be slowly spiraling into their star over time until they are eventually completely engulfed and die. This is the death spiral of hot Jupiters, and I am searching for evidence of it. But how do you detect such a thing? We can't exactly see the hot Jupiter, but we can measure the brightness of its host star. When the hot Jupiter cuts in front of the star, it will block a little bit of its light. So every time the planet comes back around, there will be a dip in the star's brightness. Now, you can learn a lot from these dips, but I am most interested in when they happen. Because if the planet is slowly spiraling into the star, these dips will start happening earlier and earlier and earlier. So if you watch the star for long enough, you can start to see a difference. But you need a long time span of data in order to notice a change, at least a decade, and we are just at the cusp of being able to do this. We know that one planet is spiraling to its death, but we know there are more out there. My thesis work involves searching for hot Jupiters that are good candidates for detecting this phenomenon. I am developing mathematical and computational tools that scan through 10 to 15 years of archived data, searching for statistical evidence of long term changes in their orbital behavior. This will expand into my PhD research, where I will take a deeper dive into some of these systems in order to understand where these ultra close hot Jupiters came from, how they got here, and where they're going. Thank you.